Hello. We will demonstrate how to use the substation monitoring system developed in Work Package 5.4 of the SEETSOC project by the Technical University of Sofia team. The substation monitoring system contains 5 different modules for identifying the condition of the transformer substation. For the purposes of this demonstration, we'll use data obtained from a working transformer substation located in Bulgaria. I will start with demonstrating the first module, the module of comparison. This module calculates the delays of the signals of electromagnetic waves at every measuring point sensor as a result of a partial discharge. First, you have to choose a folder with data. In our case, we use real-life data from 4 sensors saved in a folder named Test 1. Then, OK should be pressed. The input data is thus loaded from the computer folder Test 1, and then Calculate Results button is pressed. The software generates the results and time delays between signals delta t as shown here. In the file column, you can see the names of the measurement channels, which are 4 for test 1. The time column shows the time delay for each channel. Value, the voltage value of the measurement signal for each point, and delta t, the actual time delay between the signals. And now we press the next button to go to the module of calculation. This module calculates the coordinates of the partial discharge based on the time delays filtered in the previous module. To do that, press the Load Module button and then the Calculate button. Thus, X, Y, and Z coordinates of the partial discharge are calculated in meters. Then we press the next button to go to the module of visualization. This module shows in 3D the transformer substation, the installed sensors, and the location of the partial discharge calculated in the previous module. First, we need to virtually recreate the transformer substation model by entering the necessary data. For the purposes of this demo, we have already done that, and the system has recorded the data in a text file, transformer model text, which includes data for the dimensions of the transformer, the coordinates and characteristics of the coils, and the location of the sensors. After choosing the model, the Load Model button is pressed. The transformer is then visualized in 3D, together with the coils, the sensors, and the calculated in the previous module location of the partial discharge. You can use the zoom and rotation functionalities to see the partial discharge at different angles. The partial discharge is the red sphere seen at the bottom of the transformer, and as we can see, the partial discharge in this case is located on the tank and not in the coils. And now we press the next button to go to the module of classification. This module determines the type of the partial discharge. The user has to choose the following parameters: location of the discharge on test waveform, variability of response, relative magnitude of discharges, test voltage, and time of application. After that, the button Calculate has to be pressed and the module generates a result. The most often encountered cases are from A to N. Again, the next button to go to the module of decision. This module determines the working state of the transformer based on data from the previous modules. As a result, different measures have to be performed. Choose the case of partial discharge occurrence, the result of the classification module, the partial discharge location, in our case it is in the tank, and the oil condition. After that, the button Calculate has to be pressed and the software determines the level of criticality of the power transformer substation state. The output data is related to the state of the transformer. It can be work, attention, or danger. This informs the power engineer about the current condition of the transformer substation and, depending on the result, the necessary measures to be taken, thus determines whether maintenance or service is needed.